everything, right? Oh, 16. Maddie, let's read number 16, please.
Solve the differential equation dy over dx equals 3 cosine x minus pi when x equals pi and y equals 0.
All right. So we want to first solve for, did you read 15 or 16?
16.
Was it 16? Oh, I was not following along. Sorry. Having a moment. I'm so upset the other one didn't record. Multiply by dx. So we get dy is equal to 3 cosine of x minus pi dx. And then we're going to do what? Take the derivative? Not derivative, antiderivative. So we have our y is equal to. Okay, what should we let u equal? X minus pi. So let's write that over to the side. U is equal to x minus pi, which gives me du is equal to dx. What should I do with the 3 already? Move it to the outside. So I have, if I rewrite, we're looking at cosine of u, and we do have the dx, which is du. So let's find the antiderivative of cosine. What is the antiderivative of cosine? Sine. So 3 of the sine, 3 from the outside. And we have to add plus c because it's not bounded. And then at this point, what I need to do is plug the u back in. Yes? So when I plug the u back in, I get y is equal to 3 times the sine of x minus pi plus c. So let's see what I know from the given. It says my x is pi, y is 0. Let's plug it in right here. 0 is equal to 3 sine of pi minus pi plus c, which also gives me 3 sine of. If I take the same item and subtract it, what do I get? 0 plus c. So let's see what that basically means from last year. Here's my 0. Is that true? Sine is an opposite movement. Is there an opposite movement right here? So that tells me all of this is 0. So I have 0 is equal to 3 times a 0 plus c. So c has to be how many? 0. So if I rewrite this with the c value, it's going to give me the following. We have y is equal to 3 times sine of x minus pi, and that is our final. Oh, let's do this one on the calculator. And let's see. Ethan, will you grab me a calculator? And if y'all need one, go ahead and grab one as well. Give me number 28. I don't think anybody has that one. So some of you guys on the quiz were trying to do this by hand. Please don't. Especially if it's a calculator active question. But, all right. So I'm going to write on here what's going to happen. So our average value says the following. Let's write out average. Oh, God. That's not average. No? Yeah. I was just writing slowly. Average value. So we're looking at 1 over b minus a of the integral from a to b of whatever the function may be, dx. So from the given, we know our a is 0, b is 2. So we have 1 over 2 minus 0 of 0 to 2. And our function given is 3x squared plus 1 dx. The fraction bar you would have to do on your own, which is not a problem. 1 over 2. How do we call out the integral on the calculator? Math 9. So let's write this over. It is math, the number 9. And we got 0 to 2. To the side inside we have 3x squared plus 1 of dx. When you press enter, you should get some whole number. Boom. Okay, that was 17. Are we all ready for number 18? All right. Let's all go to number 18. And in case you're thinking, well, what part was number 18? It was second fundamental theorem of calculus. Somewhere on my card. I think it's card number 9. So all we had to do is plug in the upper bound as it is, times the derivative minus the lower bound, times the derivative. So let's practice that. Looking at this, our upper bound is right here. And we're plugging that into the domain. So let's write out 5x cubed plus the 1 all squared. And then now we have to find the derivative of the upper bound. What is the derivative of 5x cubed? 15x squared. Minus, now we're going to plug in the lower bound, the x. So I have x plus 1 all squared. What is the derivative of the lower bound?
1.
Times 1. Is that necessary? Will I take off if you forget? No. There's an understood 1. And that's it. So if you're looking at this going, well, that was easy, you're not going to miss it. Okay? Do we also need part B? All right.
Derivative of pi over 2 just 0.
Yeah, because any number is 0. Okay? So let's go on to my second one. Let's go ahead and plug in the upper bound into that variable. So we have, I should have written f prime of x. Oopsie. The capital F prime of x. I like to forget that. Not a good practice. All right. So for this one, we have tangent of the upper bound, x squared. Now I plugged everything in, so now I need to find the what? The derivative of the upper bound is what? 2x minus my lower, and of course I can't fit this, huh? How convenient. Pi over 2. Oh no. What is the derivative of pi over 2 if it's not a variable?
0.
It is times 0. So what would happen if you just wrote this and you wrote nothing with the 0? It'll be correct. What if you wrote it and wrote times 0? That is also correct. But if you forget the times 0 or putting understood 1, that will be off. All right? Are we all set?